Welcome, everyone. I'm sure there's a variety of people coming into the session. Apologies if we are running just a couple minutes late there. This session is being recorded and it will be available with the Q&A transcripts and slides after the session. So thank you for hanging in there and joining us for the last session of the day. I know it's been a long 2 days, so I really appreciate your interest in sticking with us during the data user meeting. There's a closed captioning available using the closed caption button on the Zoom ribbon. And please, if you have any questions, use the Q&A button on the Zoom ribbon to submit those questions. My name is Lisa Colson. I'm a geographer with the Foreign Agricultural Service, and we have with us Bob Tatro, who is the director of the International Production Assessment Division, and Ron Franz is the senior director as well. So the three of us are available to help answer any questions you might have as we go through talking about GADAS today. Let me go ahead and share my screen so we can get started. Good. And I want to go ahead and start at the beginning, right? Sorry, apologies. I'm like going through when we first open all my slides here, aren't I? There we go. Can everyone see the slides okay?
Yes.
Good. Great. So GADAS is the Global Agricultural and Disaster Assessment System. That's kind of a mouthful. So, you know, as most federal agencies, we like to use the acronym GADAS. It's free and available to the public. It's one of our newer web GIS applications that provides a variety of data sets, including agricultural data. For our agenda today, I want to first take a couple slides to highlight our role in market intelligence, giving you a little information on why we built GADAS. And then I'll provide an overview on GADAS, just briefly explaining more what it is. But to me, the best way to explain GADAS to a new audience is to just walk through it. So I've identified a scenario that'll allow me to show off a few of the functionality and features of GADAS. It's a big application, so we won't be able to demonstrate everything, but hopefully it'll get you interested in taking a look at it yourself. And then we'll wrap up with some acknowledgements and key websites that you can peruse on your own for more information. As I mentioned, I am a geographer, so fear not, we will also cover when and where throughout this presentation. So to cover that background, the Foreign Agricultural Service has overseas activities with attachés located at 98 offices covering 177 countries. FAS is primarily responsible for market development, international trade agreements, and negotiations, and then also the collection and analysis of statistics and market intelligence information. So it's that last bullet that our program area, Global Market Analysis, is focused on. And the world is a very large place to cover. So we leverage geospatial data to help us achieve our goals and our mission, which is to support global food crop monitoring and crop production forecasting. We consider ourselves an all sources shop. So while geospatial data helps augment information from international reports, the important things like the reports that NASS puts out there and those ag census and survey data, many countries also provide their own surveys and censuses, but not all. And so geospatial data helps augment that information. In addition, our group has to be very flexible and responsive to a variety of situations, especially when it comes to disasters. So when we look at strengthening access to data resources, our aim is to have as much information as possible at our disposal to perform a litany of tasks that allow us to respond in a timely and efficient manner. And that's even most as important during times of disasters. We find that geospatial data is an independent source of information that is objective, reliable, and timely. So all of our resources need to achieve those expectations so that they can be reliable and authoritative information feeding into our market intelligence. This also brings me to our web resources. We want that timely information. So we've shared many of our data sets with the public via our web resources like Crop Explorer and GADAS. For today's session, I'm going to focus on GADAS and talking about it. GADAS is a global web GIS system combining comprehensive near real-time Earth observation data and tools. So it's a very interactive system. And at this point, I want to call your attention to our session description. I'm going to pull out a few examples of how GADAS shows you these various features that were mentioned in the session description. So here we have that FAS developed this online geographic information system that covers and shares near real-time weather data, like the examples we see on the left here. It also provides disaster data, like the example on the top right. And all of this can be combined with spatially explicit global agricultural information, like what we see on the bottom right. GADAS enables analysts and other public stakeholders to perform comparative analysis with our side-by-side tools and conduct data mining, like you can do with the analytics tools on the bottom left. And all of this is to help us be able to create publication-ready maps, charts, or tables, like the example on the right. GADAS provides authoritative satellite imagery and satellite-derived Earth observation data to support collaboration in regional and field-based assessments of agricultural conditions. And it is best used via Google Chrome, but don't take my word for it. If you will give me just a couple more minutes, I'm going to introduce a scenario that'll allow us to walk through some examples of how to use GADAS. The scenario I've decided to pick today is a drought that happened in Australia a couple years ago, mostly because I have a feeling many of you heard about it. 2019 was a rough year for Australia that eventually led to enormous fires. And while many of these newspaper articles were covered the fires, in this scenario, we will focus on the wheat crop to demonstrate using different features of GADAS. First, we're going to review the country's crop calendar and crop geography. Second, we'll explore precipitation data to get oriented, and this will give me a chance to show you how to use the time slider. Third, we'll chart precipitation to find the drought period in our map analytics tool. Fourth, we'll map the drought. So going back to the web map under the crop conditions category, I want to highlight one of those data layers. Fifth, we'll calculate ag area affected. And this is the main tool out of all of our tools on GADAS. This is the main tool I'm going to demonstrate. And then sixth, we'll export the map product to capture the story. I sneak in a couple more tools in this last step here for you because I want to show as much as I can. So in general, going through this workflow, what we're talking about is how you can use GADAS to observe conditions, keeping in mind information about the crop calendar and crop geography. And therefore, an analyst could use that information, all that different data together, to perform crop condition assessments. Okay, so let's first look at the crop calendar and crop geography. Via the iPad website, it's easy to find our crop calendars and our crop production maps. I pulled out one example, the wheat production map of Australia on the bottom left. You can see in greens where the major wheat belt is, right? And then on the right, we have the crop calendar. So looking at wheat, generally planting happens around May, and then harvest begins in November. Those are important time periods to keep in mind as we perform an assessment. Okay, so next, let's switch to the application. When we first open up GADAS, this is how it appears with a few data layers on the map. You can see our categories of data on the left, the time slider across the bottom, and then additional features and tools across the top. Considering the quantity of data layers that are initially opened up on GADAS, and also considering that for this scenario, we want to look at drought conditions and in Australia, right? I'm going to first clear the map and then zoom to my region of interest. To give a little more context on the map of Australia, I'm going to add on some state boundaries, and then we can begin exploring some precipitation data. We have precipitation provided as 3 different variables and from a wide variety of authoritative data sources. This example, we want to focus on iMerge, and we can see with the legend what the rainfall data looks like there. You can see that the time slider is now activated, and I can easily scroll through the history of this data. And in addition to that, we have total rainfall aggregated to different time steps. So you can look at new data set every week, every 10 days, or these other monthly options. Using the calendar picker, I can go back to 2018. And so looking at the rainfall patterns towards the end of 2018, we can begin to explore how the drought developed in Australia. Moving into 2019, we can see drier conditions become more prevalent, and especially in Australia, then the dryness seems pretty persistently throughout Australia in April, starting in April, and that dryness continues for the rest of the year. So it's easy to navigate GADAS very quickly to look at different time periods of data. We have another tool we call Map Analytics that you can use to pull out time series charts by simply filling out this form. If you ever want to have a little more context about where you're requesting your chart from, you can always add on different data layers. I even want to change the croplands displayed in this map because this 300-meter option shows irrigated and rain-fed croplands. So I'm going to go ahead and click on that top croplands option, showing everything together. Let's zoom into New South Wales. So we can see with this image that the irrigated croplands are in yellow, and then the rain-fed croplands are in the dark browns. Considering a drought has a greater impact on the rain-fed croplands, let's focus on this northern part of New South Wales for our analysis. Whenever you pick a data source, the grid or stations get added to the map so that you can make your selection. We're going to use cumulative precip. With time aggregation, you can choose the number of data points you want per month. And then you can choose any month, even one later in the year that wraps into the next year that would work in this tool just fine. I'm going to pull out 5 years worth of data. And use this draw tool to select a relatively small area on the map so we don't have to wait too long. All right, we have a result. With cumulative precip, whenever it rains, the line goes up a little bit, whereas when it doesn't rain, the line stays relatively flat. As we can see here in 2019 with this blue line, the line is definitely lower and stays lower than all the other previous 5 years. So that's a simple way of using map analytics. You can see how quick it is to use this feature, huh? Access to lots of different data, and you can choose anywhere in the world to. Sorry, I just want to point out in the video real quick, one feature. Just open up GADAS. This is how it's. Second, I need to move it forward. It appears with a few data layers on the map. You can see our categories of data on the left. Well, this is the challenge I have with doing something live, right? I wanted to make one minor change. It'll let me. Apologies, I don't have any control. Okay, so those were a few of the examples of what you can do with GADAS. The one thing that I wanted to show off was to reflect some of the questions that have been asked in the previous sessions. And so let me just interrupt this video a second to show that. And I know I need to pull up the screen again. Apologies, so that I'm not sharing at the moment. So a few people have asked about how can we get access to this data? And one thing that you can do when we pull this out and get another time step. So now we're seeing this live, correct? And I'm going to pull out a chart, and you can see that it does take a little while to pull out the data, but it's not that long considering that you're pursuing 5 years worth of data, exploring the database and then dragging it back in. And so once you get the chart appearing on the screen, which it will be here soon, then I can show you how you can download the data. And so with our chart features, we have this nice download tool that allow you to export either this specific graph as an independent image file, or the data downloaded directly to a CSV, which you could open up in Excel if you'd like. That's one nice way of getting at the data. Continuing with the demonstration, as we saw, I want to zoom back out a little bit and move on to the crop conditions category. So I'm going to clear the map, and under crop conditions, we have this drought monitoring feature. If you do see that indeed there is a drought, I highly recommend utilizing this. For most of the world, this chirps option works very nicely. But one reason why it's useful to explore other data sources first is just that we do provide this standardized precipitation index data in a wide variety of time steps. So you can get new data updates every 5 days when you're clicking on these rolling options, or once a month when you're using any of the monthly options. So let me turn on the states again, just so that we have that geographical context. And then we will come back to 2019, a little earlier in the year. And so now with this June 30th image, we're looking at the standardized precipitation index that was calculated from precipitation between April, May, and June, derived into an indice. And so you can see from this legend that what we have is a very commonly well-known definition of drought severity, right? The international community and USDA's Drought Monitor talks about these D2, D3, D4 droughts. And so we have symbolized this data in that exact same way, utilizing that scientific body of knowledge and how it's displayed. Now let me go ahead and move forward through the images, and we're looking for the bright red and even the dark red categories, right? You can see how much this drought has expanded and become worse over time. Now, even though it's the most dramatic image on December 31st of 2019, whenever you want to consider thinking about using a calculation like ag area affected, well, then we want to look at a time period that's relevant to the crop, right? And as we mentioned, the crop tends to get harvested in November. So let's focus in on this August date. And that's when we could pull out one of our tools. And so we have a tool called Ag Area Affected. And one thing you can do with this is very easily calculate ag area affected. So for this example, and we're not going to wait for the results completely here. I am going to draw a smaller area so that the tool can run more quickly. So while the tool is running, I just want to explain that in order for this tool to work, you have to first open up a data set in the web map from the weather, vegetation index, or crop condition categories. Then you can choose your ag mass source and choose the area that you're gonna calculate. So the nice thing about this tool is that, you know, even though we do give you this option for a freehand polygon, you don't have to put that much work into it. You can let the tool say anywhere in this blue area, where do the croplands intersect into these different categories of SPI? And then voila, you have a calculated result. So here we're seeing approximately 3,000 hectares of wheat have been affected in the most severe drought category, and a little almost 500,000 hectares in the extreme category. So this provides you with a first order of magnitude calculation the maps are not necessarily specific to this year, but they are well respected and authoritative data sets that give you the initial idea of how severe the event might be in a way that you could compare these area numbers over time. That's useful. Now I've shown you how to look at the data. Let's say maybe you think this is a very interesting map, and so we can turn on some cities just to give it a little more information. We also can use another tool called the style editor if we want to label the states in Australia. But of course, because of this Australian Capital Territory down here, now all of a sudden this is looking really busy. Maybe I'll turn off those labels. I can make the city boundary, the city labels just a little larger. Let me make that easier to see down here. And I could also turn on the capital cities and make that label a little larger. So it's pretty easy to use the different features of this. There we go. And however you want to finish your map. When you're looking at this, sure, you can take a screen capture of it. You'll get these buttons here and the time slider in your screen capture. But we also have a tool called the share tool where you could export the images. It's a really nice way of then seeing an image like this preview that doesn't have all the buttons. And so when you're using this tool, you can give it a different file name, and just remember that there will be pop-ups asking you where do you want to save the files at the end. We also, under the share button, we have this great thing called Bookmark Your Page. You know, you just spent all this time exploring different data layers, adding on multiple data layers, saying what time period you want shown. And instead of telling a colleague, hey, I was looking at GADAS, will you click on these, 12 buttons and make this same map I just made, and then, look at this image with me. Instead, you can click on Bookmark Your Page, copy the URL, paste it into an email to your friend so that your friend or colleague clicks on that link. Now, yes, it is a very long link. You want them to be able to just click on it. But when they open up in Google Chrome, you'll see that GADAS opens immediately to the exact same data set that you were looking at in the same exact way. So that's an exciting element of how to do this, and a few different features of GADAS that allow you to share information with your colleagues. Let me switch back to my slides. I do want to make sure we have enough time for wrapping up with questions. And so in summary, GADAS is a rich visualization resource with more than 500 different data layers in it. I want to thank our partners and our data providers as these time series, as they are the main providers of the time series data sets that you see in GADAS. They're updated daily, weekly, and monthly predominantly. I did not put together this presentation by myself. I work with a variety of colleagues who are responsible for different regions of the world. So they are crop analysts who are responsible for deriving USDA's international monthly production estimates and feeding into the work of the World Agricultural Outlook Board. So we're one piece of information in that whole process. And I hope that you've seen from this example that the work that we do and how we utilize GADAS supports the ability to do agricultural monitoring of crop conditions, covering food security assessments and disaster monitoring, especially in those countries that don't have as much data access as we have for the United States. So here's a few websites. If you are interested in exploring more information, I've highlighted our circular called World Agricultural Production that comes out every month with the WASDE. It's an excellent way of getting more information about the changes to production that are published in the WASDE. And we would be happy to answer any questions that you might have. Thank you. So Bob, are you seeing any questions submitted by others?
No, not at the moment. I had placed some information about the websites in the chat. Yeah, this is a good time for folks to ask questions about, Lisa went through a lot of information, and there's all right, here we go. So this question is from Benjamin Diamond. Is the tabular data downloadable in a CSV format?
Yeah, so once you pull out a chart using that analytics tool that I demonstrated, then click on the little download option that'll allow you to download it as a CSV. And so therefore you will get tabular data for any of the data variables that you can chart.
So I think that would be the SPI drought variables, the precipitation variables. Is NDVI included in that as well, Lisa?
NDVI is included in that. We have another application we call NASA GIMS that we work with NASA to provide. And so this Global Agricultural Monitoring System, the GLAM application, is one way that you can download a greater variety of NDVI data. And so I recommend getting the NDVI data from there, honestly.
All right, thank you. No open questions, but we do have a heads up that we have 5 minutes remaining in the session. Thanks, Marissa.
Yeah. Just to give everyone a chance to think a little further, I do want to mention that you will be emailed an evaluation form on Friday. So please give us your feedback. We welcome your comments and suggestions for improvements. And we really do thank you for attending this session and the data users meeting. We look forward to seeing everyone in future events. So before I forget to say thank you for your time, I did want to mention that. But let's see if there might be one or more comments before we wrap up the session.
I have one comment or question, Lisa. Did you mention that this is open to everyone? It doesn't require a login or any of that other type of login or password or any of those types of things for normal websites?
Right, to have a website that provides so many different data sets, you would think maybe we would have to hide it behind some sort of, no, it's easy to use. You can just open up GADAS and it's free and public. There's no need for you to log in or maintain some sort of username and password to use GADAS. So we make it easier for you that way.
And one last, another comment is we're always trying to make sure that this is useful to our ag community. So if you do have comments or suggestions that you don't want to post now, but would like to contact us to make other suggestions for what you would like to see on GADAS, please don't hesitate. Both Lisa and I are able to answer those, and we would be able to put them in the queue for improving the site.
Yeah, we welcome feedback and inputs because, you know, geospatial data does change over time. So sometimes we need to swap out layers to ensure we're providing the most relevant and up-to-date information. And that gives us an opportunity to incorporate your needs as well. So please let us know what feedback you have.
Another question that's come in through a different channel is, how useful is GADAS for monitoring conditions in the United States?
That's a good question. It is useful for monitoring conditions in the United States, especially with those kind of large area events. You know, when it comes to monitoring hurricanes, we do have MODIS multispectral imagery in GADAS, and there is very few other sources of information for looking at those hurricanes in real time as they're approaching land. It's possible to do that. The disaster data layers, they come from the Pacific Disaster Center that covers global alerts. That includes the United States. So you have a lot of access. You have access to more information on any of those disaster alerts. You can click on them and find additional reports that a wide variety of agencies have contributed. It's very useful information. However, you know, our geospatial data sets are global data sets, and there are additional bodies of information for the United States that go way beyond what we have for the international community. So I do think GADAS is a good place to start, but not necessarily covering everything about the US possible, right? We did not include the full body of the NASS CDL in here, again, because we wanted to have comparable data sets throughout the world. And that degree, the cropland data layer that NASS provides is much more detailed than virtually any other data layer in the world. So because it can't compare to what's provided around the world, you do have additional US data outside of GADAS.
So the recommendation would be able to use GADAS as well as something like Cropscape to access the NASS CDL.
Oh yeah, have you looked at Cropscape? That's a really cool tool. Cropscape is much more detailed and for the United States. Yeah.
All righty. Well, thank you very much for attending this session. I think we're going to go ahead and wrap up now. And again, I think our emails will be available through the transcript of this session. So if you have direct questions for either Lisa or myself, please don't hesitate to contact us. Again, we're trying to make this a useful tool to the ag community. So please help us improve it. Thank you very much.